Today we are going to start chapter 7 of Kanski, that is of cornea. So cornea is basically a very tricky chapter because it is very lengthy and there is a lot of information on this. So without any further ado, let's get started. So first we have an introduction. So introduction, there is an anatomy and the physiology and a journal. The cornea is a complex structure which, as well as being as a protective role, is responsible for about three quarters of the optical power of the eye. So, what does this mean? What does it mean? So, normally the cornea, and there is a lens behind the cornea, and there is a retina. So what happens that all the refractive the light refract to the cornea and then refract at the lens, and then they form a point in the retina. They focus on the retina. So the cornea contributes about 3/4 of the optical property. That means that 43 out of 58 diopter is of cornea. The rest is usually done by the lens. Refraction is done by the lens. So the cornea is a complex structure which, as well as being as a protective role, is responsible for about 3/4 of the optical power of the eye. The normal cornea is free of blood vessels, nutrients are supplied, and metabolic products removed via the aqueous humor posteriorly and the tears anteriorly. So, because everything has to be clear in case for the light to reach the retina, so the normal cornea is transparent. It does not have any kind of blood vessels. And so how does it get the nutrient supply? Nutrient supply is by the, so this is cornea, and the posterior side of the cornea is getting the nutrients from aqueous humor, and in the anterior chamber, and interiorly it is by the tears. The cornea is mostly densely innervated tissue in the body, and a condition such as abrasion and bullous keratopathy are associated with marked pain, photophobia, and reflex lacrimation. So that is it. That means that basically the cornea is very innervated. So any diseases such as abrasions and bullous keratopathy causes intense pain, and there is a photophobia, which means that the eye is uh, sensitive to light, and there is an increase in the tears. A subepithelial and a deeper stromal nerve plexus are supplied by the first division of the trigeminal nerve. So basically there are two plexus in the cornea. One is and the subepithelial region, and other is in the stromal region, and both of them are supplied by the first division of the trigeminal nerve. So then comes about the dimension. So dimension is that the average corneal diameter is 11.5 millimeter vertically and 12 millimeter horizontally. It means that cornea is horizontally oval. What it means is that in horizontal it is 12 millimeter, it is bigger, and vertically it is 11.5 millimeter. It is called horizontal oval. And what happened is it is 540 micrometer thick centrally on an average, and thicker towards the periphery. Central corneal thickness does not differ between males and females, but varies between individual and races. So what does it mean? That it is about 540 micrometer thick in the, so cornea is like this. It is prolate shape. It is thin in the center and thick at the periphery. And this thinness or thickness, it varies between individual and it is between races but not between males and females. Gender is not an issue in this case. It is a key determinant of the intraocular pressure measured with the conventional technique. So, how is the thickness and the thinness of the cornea causes the change in IOP? So, it is very simple. Thin cornea, low IOP. Thick cornea, high IOP. Structure. The cornea consists of the, now we are going to the histopathology of the cornea. The cornea consists of the following layers. So, what kind of layers are these? This is epithelium, Bowman's layer, stroma, Descemet membrane, endothelium, and there is a duval layer, which is basically pre-Descemet membrane, or that is between the layer between the stroma and the Descemet membrane. So, first we are going to see the figure 7.1. So, you can see this is an anatomy of the cornea. First, you can see the figure, which is like showing that the cornea histopathology. First is the tear film. It is only the basically epithelium it is showing of the cornea. And then there is a surface cell. Then there are wing cells, and then there are basal cells. And this is a basement membrane. So what are the layers of the cornea? Epithelium, basement membrane, Bowman's layer, stroma, Descemet membrane, and endothelium. Structure. The cornea consists of the following layers. The epithelium is a stratified squamous and a non-keratinized, and it is composed of. So basically the cornea needs to be clear. So what it is made, the epithelium of the cornea is made up of the stratified squamous, but it is not keratinized. If it was keratinized, it must not have been transparent. So what are the layers of the epithelium? A single layer of the, so first we are going to chat about the columnar basal layer. A single layer of the columnar basal cell attached by hemidesmosome to the underlying basement membrane. So there is a basement membrane and there are the columnar cells. So what connect this and the basement membrane are the hemidesmosomes. And then there are 2 to 3 strata of wing cells. Then there are wing cells. 2 or 3 layers. Then what happens? So I'm going to make it like here. So this is a columnar layer. This is a wing layer. And there are 2 layers of the squamous surface cells. Squamous cells. Then there are squamous cells like this. 2 layers. So basically it is a 5-layer deep epithelium. So the surface area of the outermost cell is increased by the microvilli or microvilli that facilitate the attachment of the tear film and the mucus. After the lifespan of the few days, superficial cells are shed into the tear film. So what increases the surface area? As we know that there are tiny microvilli or microplici, which increases the surface layer, and what its function is that the tears are attached to this surface, and these epithelium sheds into the tear films and then they are gone. Corneal stem cells are located. So this was the histopathology of the epithelium. Now there are corneal stem cells. Corneal stem cells are located at the corneoscleral limbus, possibly in the palisades of Vogt. Deficiency may result in the chronic epithelial defects and conjunctivalization. So there is another thing called corneal stem cells. You know about the stem cells, anything that have a regenerative property, they are the stem cells. So stem cells are basically that generates the epithelium, continuous epithelial cells. So if the stem cells are damaged, there are no epithelial layer, so already the epithelium are getting shedded after a few days, so there will be no epithelium. If there is no epithelium, the cornea will be abraded. So the stem cells are very important. The stem cells are located at the corneoscleral limbus, possibly in the palisades of Vogt. Deficiency may result in a chronic epithelial defect and conjunctivalization, which causes epithelial. What is conjunctivalization? Is basically epithelial become unstable, and then there is a vascularization, and then there is an appearance of the goblet cells. So this is a cornea, and this is a limbus. So this is, can you say this is an eye? So in the limbus there are, this is a palisades of Vogt, which has a stem cells. They're thought to be critical in the maintenance of a physiological barrier preventing conjunctival tissue from growing onto the cornea, for example, pterygium. Deficiency may be addressed by the stem cells auto and allo transplantation. So then there is a Bowman's layer. Bowman layer is the acellular superficial layer of the stroma, and it is formed by the collagen fiber. So next layer we have is a Bowman's layer, which is basically composed of the collagen fibers, and it is acellular. Then there comes the stroma. Stroma makes up to 90% of the corneal thickness. So the most thick part of the cornea is the stroma, and it is very important. It is made up of 90%. It is arranged by a regularly oriented layers of collagen fibrils whose spacing is maintained by a proteoglycan ground substance, chondroitin sulfate and keratin sulfate. So basically it is, the cornea should be clear, so there are regularly arranged fibrils, and these are separated by a proteoglycan substances, which are usually chondroitin sulfate and keratin sulfate, with interspersed modified fibroblast keratocytes, and there are also keratocytes in it. Maintenance of the regularly arrangement and spacing of the collagen is critically to optical clarity. So they are tends to be in a regularly arranged, because if they are not, if the collagens are not regularly arranged, they become opaque. So regularly arranged is very important, because what it makes the cornea clear. So the stroma can scar but cannot regenerate following damage. So anything which damages the stroma, if there is a damage to the stroma, after that it leaves a scar, so it becomes opaque because there is an irregularity in the regularly arranged fibrils. So it scars but it does not regenerate. Next is a Descemet membrane. Descemet membrane is a discrete sheet composed of a fine lattice work of collagen fibrils that are distinct from the collagen of the stroma. So Bowman's membrane is also composed of collagen fibers. Stroma is also of collagen fibers. Descemet is also of the collagen fiber, but there are differences in the collagen of the composition of the collagen that makes us differentiate between the stroma and the Descemet membrane. So what is the Descemet membrane collagen fiber? It is basically the lattice work. The membrane consists of an interior banded zone, and that is deposited in utero, and a posterior non-banded zone that is laid throughout the life by the endothelium. So Descemet membrane has an interior and a posterior layer. So the interior layer is basically banded in, basically you can say in baby, like it is deposited in utero, and non-posterior non-banded zone, because it is not formed in baby, it is basically formed in it serves as a by endothelium, and it serves as a modified basement membrane. It has a regenerative potential. So what we have learned, that Bowman's Descemet membrane has a regenerative potential, but the Bowman's membrane does not have a regenerative property. The endothelium. The endothelium consists of a monolayer of the polygonal cells. Endothelial cells maintain corneal detergents throughout life by pumping excess fluid out of the stroma. So the endothelium has a very, very important role. It is basically monolayer and it is a polygonal cells, and what happens is that it pumps the water out of the stroma to keep the cornea clear and non-edematous. So it is very important because in the adults, the young adult cell density is about 3000 cell per square meter millimeter, and the number of the cell decreases by about 0.6% per year, and neighboring cells enlarge to fill the space. So what happens is, because they are important in pumping action, so they pump the water out. So basically these cells have high density in adulthood, that is about 3000 cells, and they decrease about 0.6% per year. And what happens is, if any of this cell is damaged, the neighboring cells enlarge and fill the spaces of the lost cell. The cells cannot regenerate at a density of about 500 cells per millimeter square. Corneal edema develops and the transparency is impaired. So what happens if the cornea has 500 cells, so it does not have a it does not function properly, and it cannot pump the water effectively. So what it causes, that it causes the edema of the cornea. And what if the cornea is edematous? There is a loss of cell transparency. Then there is a existence of the sixth corneal layer between the stroma and the Descemet membrane dual layer has been proposed, though some authorities believe this to be previously described continuation of the posterior stroma. So basically, the Descemet dual layer is between the Descemet membrane and the stroma somewhere here, and there are basically the regularly arranged posterior stroma fibers. Tip: the cornea is densely innervated and a corneal abrasion is usually associated with intense pain, photophobia, and reflex lacrimation. So that is for the part 1 of the cornea.